So using what we know about special right triangles, let's look at some examples. So we're going to start with this first example here, example 1. Now notice how it's marked. Notice that we've got the two congruent sides, which means that I have to be an isosceles right. If I'm an isosceles right triangle, then I am a 45, 45, 90 triangle. The very first thing that I do is I set up my ratio of my angles. 45, 45, 90. The next thing I do is I write down my ratio of my sides. So x, x, and x times the square root of 2. That ratio is never going to change. Please do it in these steps because these steps help you to break it down and help you to understand it better. So what's going to happen is I'm going to wind up having an equation where I'm going to have to find out what x is. So I'm going to take my given side length, which is 12, and it goes with the 90-degree angle. So I'm going to write it there. And I need to figure out what x is. And x is not 12. I'm going to set up an equation. So 12 is equal to x times the square root of 2. And I need to get x by itself. So they're glued together by multiplication. To undo multiplication, we use division. So we're going to divide both sides by the square root of 2. However, if you remember, back in Unit 5, we are not allowed to have a radical in the denominator. So x is 12 times 12 over the square root of 2, but that is not considered simplified. I've got to get rid of this radical in the denominator. And so what we're going to do is we are going to rationalize the denominator. Rationalize the denominator. So what that means is get rid of the radical in the denominator. The only thing that's going to make that square root go away is to be able to take the square root of a perfect square. So I need that radical to go away. So what I'm going to do is I'm going to multiply it by the square root of 2 over 2. Now, what this has done is mathematically I've not changed anything. If I multiply the bottom by the square root of 2, then I also have to multiply the top by the square root of 2. What I do to one, I have to do the other. But what I'm really doing is I'm multiplying by 1. Because the square root of 2 divided by the square root of 2, anything divided by itself is always going to be 1. So if I multiply, what I'm doing is I'm multiplying this fraction by 1 and I'm not changing the value at all. So now, if I continue to simplify, I've got 12 times the square root of 2 on top, and the square root of 2 times the square root of 2, I can write them under the same radical, same root, same radical, and so, hey, what do you know? The 2's come out, the radical's gone, and so I have 12 times the square root of 2 over 2. Well, one more step to simplify. What is 12 divided by 2? 12 divided by 2 is 6. Remember that 2 is not going to go with that square root of 2, okay? So it simplifies to 6 times the square root of 2. It was a lot of work, but we now know that our missing sides, the sides of the legs of the isosceles right, are each 6 times the square root of 2. And I was able to do this using my 45-45-90 ratio and then rationalizing the denominator.